Hello everyone, welcome back to Learn with Kannan. In the previous lesson, we explored what factorization actually means, how every algebraic expression is made of hidden building blocks. Today, we'll learn how to find those blocks step by step. The next method we're going to learn is the common factor method, which is the easiest and most used in terms of factorizing algebraic expressions. And here are the steps. First, we have to write each term as a product of its simplest factors. Then, we find what's common in all terms. Then we pull out that common factor using the distributive law. Whatever's left will be the second factor. Let's take a look at an example problem. Take the problem 5xy plus 10x. How do we solve this problem using the common factor method? Well, if you remember correctly, we have to write each term as a product of its simplest factors. So, 5xy can be written as 5 times x times y. And 10x can be written as 2 times 5 times x. Now we find the common factors. Here, the common factors are 5 and x. Now we pull out these common factors as 5x, and whatever's left will be in the bracket, which is y and 2. And since we have a plus in the question, we'll write y plus 2. And there you have it. That's our answer. And we can see that 5x is a factor and y plus 2 is a factor. Let's take a look at another example. Okay, so our question is 12a squared b plus 15ab squared. How do we solve this problem? Well, we have to split these terms into its simplest factors. So, 12a squared b can be written as 3 times 4 times a times b. And 15ab squared can be written as 3 times 5 times a times b times b. Okay, we split the terms into its simplest factors. What now? Here we can see that 3 is common, a is common, and b is common. So we take out the common factor as 3ab, and whatever's left we'll throw into the bracket. Here we have 4a, and we have a plus in the question, 5b. So we write 4a plus 5b. And voila, we have our answer, 3ab times 4a plus 5b. Now I want you guys to grab a pen and paper and do this question by yourself. The question I have for you is 7x minus 42. Solve this question and leave the answer in the comments. I'll pin the correct answer. Moving on, we'll learn how to factorize when a binomial is a common factor. In some cases, instead of a number or a letter, the common factor itself is a binomial, like in this example. Here, we can see that x plus 1 is present in both terms. So, we pull it out. X plus 1, and what do we have left? 2y and plus 3. So we write that in the bracket. 2y plus 3. And that's it. So remember, a common factor can be a number, a variable, or even another expression. Now, let's look at some expressions where there's no single common factor across all terms. In this case, we'll use a trick called regrouping terms. We make small groups that have something in common and then take out a common binomial. If you don't understand what I mean, don't worry, I'll show you an example. Take a look at this problem. We see that there's no common factor between all terms. What do? Well, we have to rewrite this expression. Here we can regroup the terms as 2xy plus 2y 3x plus 3. Okay, we've regrouped the terms. Now what? Now we factorize group by group. From our first group, we can take 2y common. So we write that outside. 2y. Now what do we have left? We get x plus 1. And from our second group, we can take 3 common. So we write 3 outside. 3 times x plus 1. You may recognize a pattern in these answers. We can see that x plus 1 is common in both terms. We take x plus 1 common. x plus 1. What do we have left? 2y and 3. So we write 2y plus 3. The reason we write plus 3 is because there's no negative sign here behind the 3. And would you look at that? This is our final answer. We did the same thing but in 2 stages, and that's the beauty of regrouping terms. Alright, now let's get into the juicy stuff. Factorization using identities. Sometimes, instead of common factors, we use algebraic identities. These are special patterns that appear very often. Now these are the 3 golden identities that we're going to be using. I'd absolutely recommend you to memorize these 3 for future use. If your expression matches one of these patterns, you can instantly write it as a product. Let's take a look at a few examples, shall we? Our first example is x squared plus 8x plus 16. Now the easiest way to identify which identity to use is to look at the first and last terms. We can see that x squared is a square and 16 is a square of 4. So we're going to be using this identity. A plus b the whole squared equals a squared plus 2ab plus b squared. Keep this in mind. We can write x squared as x squared, and we can write 16 as 4 squared. Now, keeping these in mind, we can substitute the values of a and b in the identity. So, we can take the a value as x and the b value as 4. Now, the problem gets easy from here. We have to substitute the values in the identity. So, substituting the values, we can write x squared plus 2 times x times 4 plus 4 squared. But wait, we're not done yet. We still have to convert this into this form of the identity. Since we already know that a is x and b is 4, we can easily substitute this for x plus 4 the whole squared. Let's take a look at another example. We can see that both of these are perfect squares separated by a minus sign. Now, what identity are we going to use? That's right, we're going to use the difference of 2 perfect sums. Using this identity, we can simplify this into 7p plus 6 times 7p minus 6. There it is. This is our answer. Here's another example. 4y squared minus 12y plus 9. Now in this case, we're going to use this identity. A minus b the whole squared equals a squared minus 2ab plus b squared. Now, looking at the latter part of this identity, you can already see it kind of looks like our question. We can simplify 4y squared as 2y the whole squared, and 9 as 3 the whole squared. We can take 2y as a and 3 as b. Keeping this in mind, we can write 2y the whole squared minus 2 times 2y times 3 plus 9. And we can further simplify this into 2y minus 3 the whole squared. And we're done. That is our answer. And that's about it for this video. In the next video, we'll explore division of algebraic expressions. If you enjoyed this, share it with your friends and teachers too. I'll see you in the next lesson, and this is me signing off. Bye.